Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 8 of a unit work, power and energy. So let's begin with today's class. In today's class, we are going to discuss about the power. So let's begin with today's class. Power. What does it mean? We can say it is a rate of doing work. That is what we call as a power. When we say rate, we understood that it is divided by the time. So if W is the total work done by a force in time interval T, then the average power can be defined as P average. It is the total work done that has been carried out divided by total time. So this P average that should be is equals to work done divided by time. Next, instantaneous power. It is the power at that particular instant can be determined by the dot product of the force and velocity of a body, provided that we are assuming that force is not going to change with the time. So instantaneous power could be written as P instantaneous, that is the dot product of the force and velocity. Please do remember that this is vector, even this is vector, this both are the vector, and the given answer, it's a power which should be a scalar, so I need to perform a dot product on this. Yes, so this is F dot V and that could be the FV cos theta. So if the work done is constant, P is directly proportional to the 1 by T. That means if time is increasing, power is decreasing and so on. This is true when work done is constant. We understood that power is a scalar quantity. This all are the information that you have already studied in your previous classes, that means in ninth grade, as well as you must have gone through this in your theory lectures or school sessions also. Yes, so we are just revising it and we will get back to the applications of the power. It's a unit, and CGS units it's an arc per second. In the SI unit, it's a joule per second, or we can say watt. It is not volt, it is watt. WATT, watt. Practical units of power, it is the horsepower. Generally, we use it. It's a 1 HP. That should be is equals to, you need to remember this relation also. It's a 1 HP that should be is equals to 746 watt. And the electrical units used to measure the consumption of electricity in kilowatt hour. In reality, this is the unit of energy. Yes, and 1 kilowatt hour we call this as a kWh. 1 kilowatt hour that should be is equals to 3.6 into 10 to the power 6 joule. This is 3.6 into 10 to the power 6. How does it arrive? Let's have a look. Kilo, it's at 1000 multiplied by watt multiplied by hour. R can be represented by 3600 seconds. So this is equals to 36 multiplied by 10 to the power 2 here, 10 to the power 3 here. It's a 3 multiplied by watt into second. We know that power, it is energy by time. So energy that is equals to power into time. It's a watt into second. This is energy. So this could be written as, it's a 3.6 into 10 to the power 6 joule. This is 1 kilowatt hour. This 1 kilowatt hour can be represented as 3.6 into 10 to the power 6 joule. I hope this is clear. Is it clear? Is it any doubts, any issue on this? Anything? Anything? No? Great. So this 1 kilowatt hour that should be is equals to 3.6 into 10 to the power 6 joule. Now let's derive a relation between average power and instantaneous power. This is very much required. Yes, a particle, we can say, starts from rest and it is moving with uniform acceleration. Let's suppose assume that gains of velocity v in time t. So if this is the situation, we can write it's a P average that should be is equals to work done by time t, And this work done according to the work energy theorem could be written as change in kinetic energy. You have been provided that it has started from the rest, so that should be is equals to half mv square minus half mu square, where u is 0, so that should be half into m into v square. So this is half mv square divided by time t. Let's just rearrange the situation according to this. It's a 1 by 2 into m into v by t into v. So according to this, we understood at the very beginning that it is moving with uniform acceleration. And when it is moving with uniform acceleration, we can use this relations. We have three all relations available of uniform acceleration. This is v is equals to u plus at. I have been given that u is equals to 0, so v is equals to at, and from this a is equals to v by t. So p average would be equals to m into a dot v by 2. Ma could be f dot v by 2, and f dot v, it's a p instantaneous. So please do remember that p average is equals to half of the p instantaneous, or even vice versa, it's a p instantaneous would be equals to twice of the p average. I hope this is clear. Is it clear? Is it is it clear? Great. Now, in reality, if I understood exact, the questions of the power could be have two or three variations in a primer basis. One of them, one of them is power is equals to work done by time. Now, the thing is, power can be calculated from work done by time, but work done have many of the approach to get it done. One approach, it's a force multiplied by displacement, a very basic approach. Second approach, integration of f dot dx approach, when this is the case when force is variable. Third approach, this work done is equals to change in kinetic energy. Next approach of work done is equals to change in potential energy. Again, this would be negative, but at this point of time we can write this. It's a work done is equals to negative of change in potential energy. One more approach, it's a graph of f to the x, and you need to calculate the area. So this all are the approach, and these are not even limited to this, but these are certain approaches from where you can have a work done. And as you can have a work done, you can divide it with time, and you can get back to the power. I hope this is clear. Yes, so these are the one of the approaches to get it done, to get the power done. Second approach, and the second situation would be the cases of power. Mostly they are the instantaneous power kind of thing was there. It is the case of f dot v. Now you have all the forces that we learn in laws of motion. Yes, and that would be having a dot product with v, and that will again back to the power. So basically power does not have its own questionnaire. Yes, it is going to use the questionnaire sets of the work done, and it is going to use the question sets of the laws of motion, where different forces would be there, and due to this forces velocity could be there. They could use a friction force, they could use a tension force, and they can use every another forces. I hope this is clear. So when you think for the power, you must understand that these two are the basic approaches. Again, there are certain questions which are using certain other requirements. They are having other requirements, and they cannot be done from this two. But almost 95 percentage of questions have been covered from this area. So when you go for that, when you go for this, always understood that how should I do this, whether I should go with this first approach or I should go with the second approach. On an average, 95 questions out of that 100 questions of the power will be solved easily Only 5 questions have a unique approach and that we can deal with. I hope this is clear. So let's understand the practical applications. Practical applications to calculate the power in various situations. So we are going to see certain situations and we are just going to utilize their formula and their remedies to get it done. Let's suppose the first situation: if a machine gun fires n bullets per second such that mass of each bullet is m, and each bullet is coming out with a velocity v, then the power of the machine gun. Yes, have you remembered this relations? Have you remember it? Yes, this was the relations when we used to deal with, we used to deal with the situations in the laws of motion. Yes, we have calculated the recoil force and all that stuff. So this that has been derived from this. So now you required a power. How should I do this? What I understand is power is equals to work done by time. If only one bullet is being fired, I should write it's an half mv square. Here here they are firing total n number of bullets. Here the n, it's a total number of bullets. Total number of bullets being fired. Yes, it has been written over here where n bullets are fired in time t. Yes, so the total work done, it's equals to n into half mv square divided by time t, and I can replace it by the n, small n. It's an small n is the number of bullets per second. It's a number of bullets per second. So average power could be written as 1 by 2 into n into m into v square. That's it. So this is nothing new to us. Only the form has been changed. Only the question patterns has been changed. So let's have a quick question over it. Do it quickly. If soldier fires, if soldier fires 1,000 bullets per second, each having mass of each having mass of 10 gram and leaving with speed of it is 100 meter per second. Find out find out power of machine gun. So from the basic relations we have the p is equals to 1 by 2 into n into m into v square. Yes, we have derived it in the last slide only. So this is equals to 1 by 2 multiplied by n. It's a number of bullets per second, which could be given as 1,000, multiplied by mass, it's a 10, but it is gram, it's a divide by 1,000, multiplied by v square. So this is 10 to the power 4. So this 3 has gone, this 3 has gone, this is 2 5s, and that should be is equals to 50 into 10 to the power 3, or I should say it's a 50 kilowatt. This is the power required if you want to fire 1,000 bullets per second from your machine gun. Yes, I hope this is clear. It was it? Does it clear? Does it? Great. Let's look at the second applications. Yes, it says that a conveyor belt moves horizontally with a constant speed v, and certain gravels are falling on it at a rate of dm by dt. So the situation is, I hope you understood this. This is conveyor belt, and when conveyor belts are there, uh, roller kinds of things or the wheels were there on which this conveyor belt slides, and on this belt gravels are going to be placed and they are going to be dropped down at a rate of dm by dt, something like this. So if I want that my conveyor belt keep moving with the same speed, what I required, it's a force that is equals to v dm by dt. Now one question should came into your mind, that according to the Newton's first law, if an object is moving with constant speed, if an object is moving with constant speed, then no force is required. Then no force is required to keep it moving. Then why we are applying a force here? Do you have an answer of this? That if an object is moving with constant speed, we look at this. Then why do I apply a force to keep it moving? Because according to the first law, no force is required for any object to keep it moving with the same speed. Here, mass is changing. It's a mass which is changing. Yes, so this is directly or indirectly the case of the variable mass system, because initially only the conveyor belt was there. Now we are going to drop down certain gravels, and that will increase the mass the of the system. Now the system contains a certain gravels plus mass of the conveyor belt, and that's why we are applying a certain force over here, which could be written as F is equals to V into dm by dt. I hope this is clear. Now let's suppose I want to find out the extra power required to drive the belt. Yes, this is equals to F dot V. F could be written as V dm by dt, and this is multiplied by V. It's a P is equals to dm by dt into V square. I hope this is clear. Is it clear? Is it is it clear? Yes, great. A same kind of questions can be asked something like this, that if a water is coming out through a pipe of length L and cross sectional area of pipe is A. Water is coming out through a pipe of length L, cross sectional area of pipe is A, with velocity V. With velocity V. Find out power delivered to horizontal to wall if water have been struck to the wall. So the situation is, let's suppose this is the wall, and on this wall we are striking this water jet. Yes, this is the cross sectional area A, with which this is the velocity V, with which water is coming out. This is the length L and onwards. So what we understand is that P could be written as F dot V. Now my first task was to calculate the F. How could I do this? We have done this previously in the laws of motion. We know this, that F is equals to V dm by dt. Now let's just replace the mass by density into volume, and volume by area into length. So this is rho into A into V multiplied by dl by dt. This dl by dt would be again V, it's a rho into A into V square. So this is equals to rho into A into V square into V. This is equals to rho into A into V cube. This is power. I hope this is clear. This is clear. Any issues in this? Anything? No? So from this at one of the examinations, question has been asked that, look at this question, that if initially velocity of water that is coming out from the pipe is V. Now, if velocity increases, if velocity increases by 2v, find out ratios of their forces, that means previous force and initial force, and and ratio ratio of their power. So so how could I do this? Now, in this situation I must understood that my force was directly proportional to the v square and my power was directly proportional to the v cube. So if I go with this, it's an f2 by f1. This is equals to 2 stands for the new, 1 stands for the initial. So initially the water is flowing out with a speed v. Now if velocity increases by 2v, that means final speed is not 2v, it is 3v, because v was already there and it has been increased. It has been increased by 2v. So this is 3v whole square divided by v square. This is equals to 9 is to 1. I hope this is clear. And now let's do it for the powers. So for the power I can have like this, it's a p2, it's so p1 that should be is equals to 3v cube divided by v cube. 3 cube, it's a 27, it's a 27 is to 1. So this is 27 is to 1. Let me rewrite this. Yes, I hope this is clear. Is it clear? Is it clear? Yes, I hope this is clear. Is it? Got it? Great. So shall I write one more question for you? But I'm not going to do it. You yourself is going to do it. That if balloon of mass 10 gram is with filled with air of 10 gram in it. Now if its mouth is open, due to which 1 gram of air is coming out, 1 gram of air is coming out per second, and it is moving in upward direction. It is moving in upward direction with speed v is equals to 20 meter per second. Find out power. Yes, so this is try yourself. This is try yourself. I can give you the hint that this is the variable mass system, and when it is the case of a variable mass system, we can have F is equals to V dm by dt, and then P is equals to F dot V. I hope this is clear. Done? Done? Well done. Great. So let's move to the next application. It says that if pump lifts the water from depth h and delivers at a rate of dm by dt with a velocity v, then the power delivered. Yes, a very good application. That is something like this, that let's suppose a well kind of thing would be there, or power or water has been stored at the underground tanks. This is the water. we have set up a certain power, we have certain power cable, and this is used to bring this water from this to this, from bottom to edge, and then it is going to deliver it with speed v. This is the situation. So what I need to do is that I understood that power is equals to work done by time. Now here I have two tasks. One task is to bring this water from down to this, and that could be done by mgh. So I have given this, it's a dm by d2 into gh, it's a mgh divided by time. And one more task is to throw this, to deliver this at a rate of dm by dt and with speed v. So that would be equals to dm by dt into v square by 2. So if I simplify this, this is nothing but it's an mgh plus half mv square by t. So I am here doing two tasks. One, to bring this water from down, from the bottom to the edge height, and then I'm going to deliver it. Then I'm going to deliver it with certain speed v within certain amount of time t. I hope this is clear. This is one of the favorite question. I don't understand why, but people love this. So let's have one of the question on this, that find out power of pump required to bring 1000 kg of water from depth 10 meter to, from depth 10 meter, and and delivered it with a speed of 10 meter per second for every hour. Yes, look at the data. What do we want? We want the power of a pump required to bring how much? It's 1000 kg of water from where? From depth 10 meter, and we need to deliver it. We need to deliver it with a speed of 10 meter per second for every hour. This is given. So power could be written as this is mgh plus half mv square divided by time t. So the this could be solved as m, it's 1000, multiplied by g, 10, height again 10, plus 1 by 2 multiplied by mass, it's a 10 to the power 3, multiplied by velocity, it's a 10 square, divide by it's a time, it's a 3600. I hope this is clear. So if I want to solve this, it's a 3 plus 1 plus 1. Yes, so this is 10 to the power 5, this is 10 to the power 5 plus 1 by 2, it's a zero point 0.5 into 10 to the power 5 divide by 3600. So that could be power is equals to 1 plus zero point 0.5, matlab that means 3 by 2 into 10 to the power 3 into 10 to the power 2 divide by 36 into 10 to the power 2. Yes, I have done the same thing. This is 1 into 10 to the power 5, this is zero point 0.5 into 10 to the power 5. Yes, so this is 1, this is 1 by 2, that I have written over here as a 3 by 2. Here it was 10 to the power 5, it's a 10 to the power 2, it's a 3600. So I have just divide this into 36 into 10 to the power 2, so that this could be a cancelled out. This is 3, this is 36, so it's a 12. So this is equals to 10 to the power 3 divided by 24. This could be written as 1000 divided by 24, which in turns could be 500 by 12, which in turn could be 200 by, sorry, it's a 250 by 6, and that could be a 125 by 3. It's a 43s are 120 and 43s are 125 would remaining 41, It's a 41.66 volt. This is the power required. I hope this is clear. Is it clear? Is it? So can we do this? Can we? Is it possible for us to get it done? Are you sure? Great. You are doing good job. Yes. Very good job. Now let's work for this question. The car moves on a rough horizontal road. Rough. Have a look at this. With a constant speed of v, then the instantaneous power of engine is required. Okay, so again the same thing, that if it is moving with constant velocity, why do I require a force to be applied? Because this is not a smooth road, it is the rough road. So as it is rough road, it must be having a friction over here. Let's say coefficient of static friction over here is mu. Yes, so what you need to do is, it is moving, it is, or it needs to move with constant speed. And when it needs to move with constant speed, this is the F external required, which can just balance this F. So what you need to do, you need to find out this external force, which should be equals to the friction force acting on this body. If you are going to satisfy only the friction, then net force is 0. And if net force is 0, if net force is 0, your body, your car can move with the constant speed. I hope this is clear. So this is P is equals to Fv, but this F external should be equals to frictional force. In this situation, friction should be equals to mu s into n, and according to the figure I can have, it's an very easy for me, it's an n, this is mg, so this is equals to mu s multiplied by mg. This is the force, this is the force of friction. So the power I should write, it's mu mg into v. This is the power that I require. Is it clear? To make it moving with a constant speed. Yes, let's have a question on this. Find out power of the car required so that it can move with constant speed of 20 meter per second. So this is the situation. This is the car, and this car is having a mass of 10 kg. It is moving on this surface. That surface is having mu is equals to 0.3. So first let's just find it out, maximum static friction, that should be is equals to mu into m into g, and that mu could be written as 3 by 10 multiplied by mass, it's a 10, multiplied by g, it's again 10, it's a 3 tens are 30 newton. This is the maximum static friction working. Now what I want that this is keep moving, this is keep moving with a speed of 20 meter per second. So this is speed, power should be written as F dot V, and this is 30 multiplied by this is 20. This is of 600 watt. Yes, yes, I hope this is clear. Is it clear? Is it? So can you do this? Can you? Is it easy? Yes. Let's have one more question. Let's suppose this is a wedge and this is angle theta. A certain block is there, A is having mass m. So you are going to apply a force from here. This is H. The slant edge has not given to us. So what I need to do is do what I need to do is that find out power required so that block M can move on the smooth wedge. Block N can move on the smooth wedge with with constant speed v. This is required. So what I need to do is, let's have a FBD of this system, that which are the forces that is required. So only as it is a smooth wedge, only one force was acting, was the mg sine theta. And if you want that this block should be moving in the upward direction, then your F external should be such as it can balance this mg sine theta. If it has been done, if you can capable enough to provide the external force which is equals to in magnitude mg sine theta, the net force on this direction, net force on the given direction is 0, and the block can move very easily with same speed. So what I need to do is, a P is equals to F dot V. Yes, you can see the both are having the same direction, and as both are having the same direction, this F could be replaced by mg sine theta into V. That's it. It's an mgv sine theta. Got it? Got it? Are you sure? Are you sure? Great. Now let's add up something to this, that in the previous question, if we replace the smooth wedge by rough wedge, find out power required. So let's suppose understood that if we are going to replace the smooth wedge by the rough wedge, we need to find out the power required to move this block. We need to find out the power required to move this block with velocity v. How should I do this? What can we do? So what I understood from this is that, let's suppose this is the situation. This is an angle theta. Now initially it was smooth wedge, now it is a rough wedge. Let's suppose your block is here. So which all forces are acting? Now you must understand that mg sine theta would be acting on this direction, and as this block is moving in the upward direction, even friction should act in this direction. So mg sine theta and friction are acting downward to the wedge, and I need to apply the F external on this direction. So now in this case, if I am capable enough to provide F external, which should be magnitude wise addition of mg sine theta and friction force, this block can move in the upward direction. With speed v. So let's just write it down. What is friction? The maximum value of friction could be written as mu s into n. From the previous sessions we understood that n is equals to mg cos theta, so this is equals to mu s into mg cos theta. This is equals to the friction. So the F external, that is what I required, it's an mg sine theta plus friction, that could be written as mg sine theta plus mu mg cos theta. So the power required. The power required, it's an F dot V. That should be is equals to mg sine theta plus mu mg cos theta into V. This is the power required. Got it? Got it? Any confusion? Any confusion? No? So can we do this? Can we? Can we do this? Are you sure? Are you sure? Can we do this? Great. So now let's have certain MCQs and we will back to the numericals again. So let's have certain MCQs. It says that the dot product of force and velocity, yes, it's an F dot V, it's a power. That's it. Yes. Second, it says that if a vehicle moves with constant speed V against the friction, then the power of the engine, yes, something like this. It is moving in this direction with speed V. It says against the friction, that means this is a rough surface having coefficient of static friction mu. And what I need a power. So as it is moving in this direction, this is F external required. If it is moving in this direction, so friction would be in this direction. This is having mass m. As it is having mass m, this should be normal, this should be mg, and the power should be is equals to F external dot V. So the F external should be equals to the friction, or I should say should be equals to the maximum static friction, and F could be written as mu s into n into V. So this is equals to mu s into mg into V, or I should say it's a mu mg into V. This is the power required. I hope this is clear. Is it clear? Is it any doubts over here? No? Let's look at this question. That it says that a particle is moving along x-axis under the action of force F, which varies with its position, which varies with its position F directly proportional to the 1 by x to the power 4. Find out variation. Find out variation of power due to this force with x. So this is required. How will you do it? Go through the data once. It says that a particle is moving along the x-axis under the action of a force F, and this force F is varying with 1 by x to the power 4. So this is something like this. It is F directly proportional to the x to the power minus of 4. You need to find out the variation of power due to this force with x. So this is given, force is given. What I required is that if I want to reach to the power, I should be having power is equals to F into V. So force already given, I required only the V. How should I do this? How should I do this? So I have been given F directly proportional to the x to the power minus of 4. What I can do is that m into a directly proportional to the x to the power minus 4. As I understood that in this situation acceleration mass is going to be constant, and that's why acceleration should be proportional to the x to the power minus of 4. From acceleration I should reach to the velocity. How should I? So acceleration is directly proportional to the x to the power minus of 4. I can have this relation. It is v dv by dx directly proportional to the x to the power minus of 4. So this could be written as v dv directly proportional to the x to the power minus of 4 into dx. Let's integrate this on both the sides. That should be v square by 2 proportional to the x to the power minus of 4 plus 1 divided by minus of 4 plus 1, and this could be v square to the v square directly proportional to the x to the power minus of 3. As we are dealing with constants only, we can omit all the, we are dealing with proportionality, so we are going to omit the constants. So this v directly proportional to the x to the power minus of 3 by 2. Now I am having a velocity, I am already having the acceleration, so let's just get the power. The power is equals to f dot v. F is proportional to the x to the power minus of 4. Velocity, it's a proportional to the minus of 3 by 2, so this is equals to x to the power minus 4 minus 3 by 2. That should be, or I should write, it's a proportional to the minus of 8 minus 3, it's a minus of 11 by 2. This is your power. I hope this is clear. Is it clear? Is it? So can you do this? Can you? Great. Ready for the next question? Let's look at this. It says that position x of a body can be given as x equals to 3t square. Find instantaneous power. Find instantaneous power delivered to the body by force on it at t equals to 3 seconds. So this is required. What do you need? You need to find out the instantaneous power. Now for the instantaneous power, we understood that it's a f dot v, and this f can be calculated with the help of m into a dot v. So my first task is to calculate acceleration. How could I do this? I am having x which is equals to 3t square. So let's just differentiate it and get the velocity. It's a dx by dt. So this is d by dt of 3t square, which should be equals to 2 3s are 60. What I want an acceleration. So acceleration, again it's a dv by dt. That should be is equals to d by dt of 60, that is equals to 6. It's an acceleration. So acceleration is fixed, which is 6 meter per second square. So if I want this, that acceleration is 6 meter per second square. Velocity is 6 into t. So if I put up at t equals to 3 seconds, 6 into 3, that would be equals to 18 meter per second. So it's a, let's assume that mass of a body is 1 kg. So this is 1 multiplied by acceleration, 6 multiplied by velocity, it's an 18. 18 6 are 108 watt. I hope this is clear. Is it clear? Is it? Have you done it? Have you? Will you be able to solve this? Are you sure? Any issues, any concern, any doubts over here? No? Great. Now let's work for the efficiency of crane, or somewhere it has been asked that find out the efficiency of the motors. So when I have been asked to find out the efficiency, I must understand that efficiency is always the ratio of the output to the input. Here we are dealing with the power, so it is the ratio of the output power to the input power, and generally it has been measured into the percentage. That's why we have multiplied it by 100. So efficiency could be written as output power divide by input power multiplied by 100. Somewhere it has been asked that if efficiency is given and input power is given, you have been asked to find out the output power. So that can be easily calculated with the help of normal mathematics. It's an efficiency multiplied by input power divided by 100 and this kind of stuff. I hope this is clear. Or let's suppose I have been given an output power and efficiency, and if I required input power, then input power can be calculated as P output divided by efficiency multiplied by 100. So this can be done. I hope this is clear. Is it clear? So let's do a question based on this. First, write it down. Take a time of 10 seconds and get it done. Have you done it? Have you? Have you done it? Great. So let's look at the question based on efficiency. It says that pumps an engine pumps 500 kg of water through height of 20 meter in 10 seconds. Find power of an engine if if its efficiency is, let's say, 90 percentage. Find out the power of the engine if its efficiency is 90 percentage. So what you need to do is first find out the work done by an engine that it has performed against the gravity. So what is work done against the gravity? It is an mgh. Yes, the mass it has pumped to 500 kg of water, it's a 500 multiplied by g, it's a 10, and multiplied by this, it's a 20. So this is 2 1 3 1 4 and 5 2 is a 10. So it's a 10 multiplied by 2 plus 1 plus 1, it's a 10 into 10 to the power 4, it's a 10 to the power 5 joule. Yes, this is the work done. So according to this work done, it has performed in 10 seconds. So it is the power, it's a work done divided by time, that would be equals to 10 to the power 5 divided by 10, which should be a 10 to the power 4 watt. Now they have given that this engine has an efficiency of the 90 percentage. So let's calculate that if power of the engine if power of the engine is P, then P multiplied by our efficiency is 90, so it's a 90 divided by 100, that should be is equals to 10 to the power 4 watt. That means 10 kilowatt, 10 into 10 to the power 3. Yes, so now let's just calculate power. It's a 10 into 10 to the power 3 multiplied by 100, which is 10 square, divided by 90. Yes, so this is gone, and 10 to the power 3 into 10 to the power 2, it's a 10 to the power 5 divided by 9. This is the watt of power. This is the power of the engine. I hope this is clear. Is it clear? Yes. Any doubts on this? Anything? Do you have any doubts, any concern over this? Anything? Are you sure? Okay, great. So let's just wind it up the session over here. This is all about the power, but this are not limited to this many questions or only. because once we have been gone through the previous year asked questions as well as some certain extra questions, we are going to do rest of the questions. But before you tune into that, please revise this basic concepts and the level 1 questions of the power. Thank you. Have a good day. Take care.